Hey everyone. So you have your Fortigate and its switchboard includes physical ports. Each can be configured with its own IP address or be associated to a virtual switch, either a soft switch or a hardware switch. That is, we are actually creating switches within the physical switchboard. But what is the difference between a soft switch and a hardware switch? Well, the difference is that in soft switch, the implementation itself is done at the software level and not on the hardware level. That is similar to saying, okay, port 1, port 2, port 3, you all belong to a soft switch that we will name it marketing, and it will have an IP address of 10.0.0 and so on. In a virtual hardware switch, the implementation is done over the physical ports themselves, where each port, each interface is configured in its hardware level to be a part of the same hardware switch. That is a much superior way to handle traffic, and in terms of performance, it makes a huge difference. Now, whenever traffic enters the switch and it is destined to one of the interfaces that belong to that switch, decisions are made by the physical switch itself, its forwarding table, which is actually the MAC table. Alright, so let's configure a hardware virtual switch. Alright, so let's move over to our command line, config system virtual switch. And now if I'll type the get command, I will see that currently I don't have any virtual switch already configured. So let's name one. Let's call our virtual switch, let's call it marketing. And let's set it up from the physical switchboard. All right, and now let's configure the different ports that will make out this switch. So let's use internal 4 and let's use internal 5 also, and let's use internal 6. All right, let's get back to our. All right, so now let's use the same command as before. Config system switch. Config system virtual switch. And let's see if we have a switch that is configured. Yes, we have. Here's our marketing switch. All right, now let's refresh our interface pane to see our new virtual switch. And there it is. Now, if we will head over to our setting page of that switch, we can configure its IP address, its management. Let's use LAN2 as our alias, and let's get him an IP address, and that's right. I'm using the same. Let's allow anyone to connect to it using HTTP and HTTPS, and let's allow ping also. And every device, every appliance that will connect to that subnet will get an IP from its DHCP server. And let's also add up device detection. Okay. And there we have it. We have a hardware virtual switch with its own subnet, with its own DHCP server. Any appliance that will connect to it will get an IP address from its pool, and any traffic that will head up to one of the interfaces that is within the marketing switch will be forwarded using the forwarding table. Let me show you the best user setting tips for your Fortigate, and we start right now. To get more easy setup tips for your Fortigate firewall, subscribe now and don't forget to click on the bell notification and you won't miss anything. So you have your users connected to one of the interfaces in your Fortigate and you want to set up different settings as authentication timeout and so on. So head over to the command line, config user settings, and the first command is set auto timeout. Let's move over between the different options, and there you can choose different integers from 1 minute up to 24 hours. Now the default is 5 minutes. Personally, I prefer to set the timeout to 30 minutes. So choose whatever suits you as an administrator and your company's policy. The second command is quite important. Set auto timeout type. Now there are different types of authentication timeout. There's the idle timeout, the hard timeout, and the new session timeout. What is the difference? In an idle timeout, Fortigate has to see traffic that is coming from the user. If it doesn't see traffic coming from the user's IP address for the time we configured as the authentication timeout, well, it deletes the authentication entry and asks the user to authenticate again. Now, in a hard timeout, it doesn't matter if there is a traffic or not. After the authentication timeout passed, the user will be asked to authenticate again. That's a hard timeout. The last option, use session timeout. Well, that's the case where you have a timeout. Let's say it's 5 minutes. You head over to a site, you start to download a file. Now, after 5 minutes, the file download is not terminated. It still goes up and downloads to your computer. But if you head over to another site, that is, you create a new session, you will be asked to authenticate. Another option that every administrator needs to configure is the amount of failed attempts before the user is being blocked. That is the number of time a user can fail authentication until it is being blocked. Now, the default is currently 5. You can change it up to 100 times. I usually use 3 times. So that is set auth invalid maximum, that is the maximum number of invalid login attempts, and let's set it to 3. Some of your user will probably head over through a captive portal, that is outsource employees and so on. So you can set the set auto portal timeout, that is the amount of time that those employees will need to authenticate again, to an integer of between 1 up to 30 minutes. One of the key elements of any authentication scheme is the usage of passwords. We use passwords all over in our FortiGate. We use it when we configure new users. We use it when we configure our admin profiles. We also use it when we configure SSL or IPsec VPNs. We use passwords all over. We will look at password entropy, how random or how difficult it is to predict your password. Let's start. So an entropy in plain words is the difficulty in guessing a password either in a brute force attack or a dictionary attack. Now, how do you calculate entropy? Well, you do it using the length of your password, the complexity of your password. Are you using uppercase characters, lowercase, or maybe you're using uppercase and lowercase? Are you using symbols? Are you using numbers? The more complex your password is, there is much more entropy. And the last parameter is the randomness of your password. The more random it is, it adds up more entropy. Now, randomness is an issue when it comes to computers, since computers can actually generate a pseudo-random numbers. All right, so let's look at an entropy example and things will be much more clearer. So we are calculating entropy using the following formula. H equals L. L is the length of your password. H is the total binary bits of an entropy. Entropy is calculated using bits. And N is the number of possible symbols in a password. So a password length of 8 characters from the entire alphabet, that is uppercase, lowercase, symbols, and numbers, will get us to an entropy of 2 to the 52. So this password has about 52 bits of entropy, and it is a strong password. The higher your password entropy, the less predictable your password patterns are for a computer. As far as password, 36, 37 bits of entropy are rather good. Another example is when we use a keylog that has only 10 digits, that is 0 to 9. So if we use only 5 characters, you know what? If we use 4 characters, we usually use 4 characters as our passwords in a panlock keypad. So that is 10 to the power of 4. 10 to the power of 4 is 10,000. So the key space of the password is 10,000 passwords. If we use 5 characters out of the 10 digits, it is 10 to the power of 5, which is only 100,000 passwords, and the entropy is only 16 bits. So this is not a good password in the digital world. It may be a good one in the physical world. If we use only lower letters in the English alphabet, we have 26 letters in the English alphabet, and we use a password of 7 characters. That is 26 to the power of 7. It gets us to a total of 8.3 billion passwords. The entropy there is 32 bits only, so still it is not a good password. If we use 8 characters out of the 26, that is 26 to the power of 8, we have 208 billion possibilities. That's the key space. The entropy is 37, which is quite good, though nowadays we use passwords with more complexity, that is using the uppercase and the lowercase plus numbers and symbols. We can use the command line to diagnose and learn more of our SD-WAN member interface. Coming up. To get more easy setup tips for your Fortigate firewall, subscribe now and don't forget to click on the bell notification and you won't miss anything. We can use our command line while configuring SD-WAN for different tasks. One of them is to use different protocols that will be used towards the server that was chosen in the health check. So if we look at the performance SLA, let's choose one. And we can see that on the graphical user interface, we only have two options to ping our server, that is using ping and HTTP. Now, if we will use the command line, config sys virtual WAN link, config health check. Now let's edit the performance SLA that we have chosen, that is SIP. Let's see what is chosen. Show full configuration, and we can see that the protocol that was chosen is ping. Let's set protocol, and now you can see that we have the ping option, the TCP echo option, the UDP echo option, HTTP, and TWAMP. So that is something that is available on the command line and not on the GUI interface. Another thing that we can do or actually see using our command line, let's use the diag sys virtual WAN link. Let's choose the SIP. You can't see it that way. Let's choose the SIP health check. Now we can see the status of each member in our SD-WAN, in our virtual SD-WAN interface. In terms of packet loss, we can also see it on the graphical user interface, but that is also one way to look at the different members. We can see that it is alive. We can see that we have no issues currently with packet loss. And we can see the statistics for latency and jitter. Currently, the other members are not alive since I have not enabled them on my Fortigate. Now, whenever we use performance SLA, we are actually telling our Fortigate to probe different services. We can configure up to 2 servers that will be used as beacons. We are doing that to check the status, the health of the different members of the SD-WAN interface. Now, whenever our Fortigate probes that server, it is actually using a route entry that is created. Let's see that route entry. So we will use the get router info kernel. And those entries are actually flagged. They are created in the kernel. They are called fib entries, and they are flagged as proto 17. So to see them, we will use the grep command, and we will use the proto equals 17, and we can see, let's make that a bit bigger. We can see the different routes. They are being sent from the different interface gateway towards the different servers that we have chosen. The first one was actually the Google DNS server, which is 8888, and the second one is 1111. Hey everyone, so here we are at part 4 of certificate operations in your Fortigate. This video series spreads some light on the importance of certificates and why do we use them. It is not a tutorial of how to create a self-signed certificate. We will get to that. It is actually the theory behind digital certificates. So what did we have? We had symmetric encryption, where the two parties share the same secret key. We also learned of asymmetric encryptions, where we use a key pair, a public and a private key, different keys yet related mathematically. And then we had, at part 3, we had hash functions, a one-way function that takes any input and transform it into a digest, a hash value that is not reversible and is collision free. That is, no two different inputs can produce the same hash value. Alright, so let's connect the dots. A CA, which is a certificate authority, issues digital certificate. This digital certificate also contain the public key of the entity who requested the digital certificate. It can be just about any web server out there. Another thing that it does is signing the digital certificate. How it does so? It hashes the digital certificate along with the public key and then encrypts it using its private key, using the CA's private key. Now, when a browser connects to a secure web server, it gets the certificate along with a digital signature. Think about it as two different files. It opens the digital signature using the public key of the CA. It has the public key of the CA in its certificate root directory. Now, any browser keeps its certificates, its CA certificates, in a different place. Now, as the file is being decrypted, he gets the hash of the digital certificate value. He then takes the digital certificate, the original one, hashes it using the same hash algorithm that was used by the CA. The type of the algorithm is also present on the certificate itself. We can see it right here. If both hash values are the same, then we have a proof that the entity who sent the certificate is the one who it claims to be. So we have used asymmetric encryption and hash functions to prove the authenticity of the entity. Now, the two parties, the browser and the web server, will negotiate the symmetric encryption that will be used as the encryption algorithm, the cipher itself, to encrypt the communication between them. We saw that we can list processes, sort them out, and even terminate them whenever they demand too much resources. On our last part of knowing your processes, we will see how we can, in one CLI command, see the topmost CPU demanding processes. To get more easy setup tips for your Fortigate firewall, subscribe now and don't forget to click on the bell notification and you won't miss anything. One of the features that we saw using the dag systop command is that we can list the most demanding processes, either CPU and memory, using the M and the P character when it is pressed. Now, there is another command, which is the get system performance top, which lists only the most demanding CPU processes. Let's see it in action. So we use the get sys, sorry for that, get sys performance top. Now you will see the most demanding processes, the most CPU demanding processes at the second most right column. That's the CPU column. The most right column is, as we know, the memory column. Now you will see different processes such as the IPS engine or the antivirus scanner, new CLI, or even the SSH daemon. Now, whenever a process is too demanding in terms of CPU, you may need to kill that process, and we saw how to do it using the diag sys kill with a signal level and the process ID. Whenever you open an app in your Fortigate, you're actually creating a process. A process is responsible to ask the kernel for resources, CPU resources, RAM resources. How do you manage them? Using the diag sys top command. Let's take a look. To get more easy setup tips for your Fortigate firewall, subscribe now and don't forget to click on the bell notification and you won't miss anything. There are some different ways to sort up the processes that are running on your Fortigate, but one of the most popular diagnose command is the diag sys top command. Now, whenever you launch the diag sys command, you will see the different processes that are currently running on your Fortigate. Now, you can filter those processes using the diag sys top, and now you can set up a number, an integer that will actually behave as the interval between the processes and the amount of processes that you wish to see. I've chosen 5 and 20 processes. So I have 20 processes and the interval that they will refresh is 5 seconds. Now let's take a look at the information that is being shown here. Let me stop just to look at those processes without interfering. So what I have here is the name of the process. New CLI is the JavaScript command line, HTTPS, the DNS proxy, and so on. I also have the process ID, which I may use if I wish to kill that process. I have the state of the process, which can be a process that is running, as this one, or a process that is asleep. Moving on to the 2 more pieces of information that we have. The first one is the amount of CPU that a process is using, and the second one is the amount of memory that the process is using. Now you will also see above the processes some gibberish, such as the 99i. What does it mean? It actually means that currently the CPU is currently 99 idle, so there aren't many processes that consume the CPU resource. You can also see the amount of free memory that our Fortigate has. That is the number that comes with the F character on the right. And lastly, The 1S actually means the percent of system processes that are using CPU. In other words, that is actually the CPU usage in percent of system processes. That's the overall information that we get using the DAG system. But how do we kill processes, and how do we toggle between processes that consume more CPU or more memory? That is coming up in the next video. Once you have deployed your access point or bunch of access point in your company space, get familiar with the term channel utilization. The more it is utilized, that is the percent of time the channel is busy transferring packets, when more energy is detected, the less throughput you will get. To get more easy setup tips for your Fortigate firewall, subscribe now and don't forget to click on the bell notification and you won't miss anything. When you deploy real-time applications such as voice over IP and video streaming, the recommendation is that you won't have more than 50% airtime utilization. Now, what makes it utilized? Bunch of things. Many SSIDs that send beacons in the air takes up airtime. That's why you don't want too many SSIDs in your network. The beacon interval, which usually is 100 milliseconds, is also responsible for the utilization of your channel, and old clients that support the old standards of B and G also utilize a lot of airtime. So what do? For start, let's change our beacon interval in our access point, and trust me, you will see a dramatic change in the channel utilization. So let's head over to our command line, config wireless controller. Let's make it config wireless controller WTP profile. And now let's edit let's see what we have. We have only a radio that supports 11N, but that's okay. And now let's config radio 1. Alright, and let's set the beacon interval. As I said, usually it is 100 milliseconds. We can put an integer between 40 milliseconds and up to 3.5 seconds. Let's put the 300 milliseconds, so every 300 milliseconds our access point will send a beacon frame, and that will lower the channel utilization significantly. We have already learned how we can list system processes and show their output on the command line. Now on this video we will look at how we can kill different processes that consumes too much memory or too much CPU power, and how we can list the highest demanding processes on our Fortigate. To get more easy setup tips for your Fortigate firewall, subscribe now and don't forget to click on the bell notification and you won't miss anything. So you're using a high-level encryption in your VPN, you're using IPS to scan different patterns and anomalies, you're using antivirus, and you keep logging of just about anything. Well, all of that consumes lots and lots of CPU resources and memory. Let's take a look at the DAG system command. Let's make an interval of 20 and with 10 processes. Alright, now using the M character, you just need to type the M character. We can sort out the processes that consumes the highest memory and in our case it is the DNS proxy. If we press the P character, that P is for CPU, we will see the different processes that consume the highest CPU resources, and in our case it is HTTPS daemon. Now the next step is to kill the process that causes you lots of issues. That is the last step before you reboot your Fortigate. Let's do a Control C. To kill a process, you use the diag kill. Now you enter what is called a signal. That is a term that comes from Linux and Unix, which is actually a polite way to ask your system to stop the process, and it can be a more aggressive way to tell your system, it depends on the number, to tell your system to kill the process. Now we can use different signal numbers. We will use 15, which is an aggressive way to tell your system kill that process, and we will list the process ID. Now the process ID, as we know, is the second column. So let's use the DNS proxy process, which is 94. Alright, now we have just killed that process. And here we can see that the DNS proxy process has actually been terminated. We saw that we can list processes, sort them out, and even terminate them whenever they demand too much resources. On our last part of knowing your processes, we will see how we can, in one CLI command, see the top most CPU demanding processes. To get more easy setup tips for your Fortigate firewall, subscribe now and don't forget to click on the bell notification and you won't miss anything. One of the features that we saw using the diag command is that we can list the most demanding processes, either CPU and memory, using the M and the P character when it is pressed. Now there is another command, which is the get system performance top, which lists only the most demanding CPU processes. Let's see it in action. So we use the get sys, sorry for that, get sys performance top. Now you will see the most demanding processes, the most CPU demanding processes at the second most right column. That's the CPU column. The most right column is, as we know, the memory column. Now you will see different processes such as the IPS engine or the antivirus scanner, new CLI, or even the SSH daemon. Now, whenever a process is too demanding in terms of CPU, you may need to kill that process, and we saw how to do it using the diag sys kill with a signal level and the process ID. So your access points have been deployed. How can you limit the amount of clients that will connect to your access point, to a specific access point? Client limitation is crucial whenever you have high density deployments and you want your clients to move between access point whenever there is a good signal strength between them and an adjacent access point. Well, you can limit the threshold, you can limit the amount of clients. It can be 10, 20, 30 clients per access point. But you can also control the threshold, the load balancing threshold. So whenever a client has enough signal strength to another access point, it will roam to that access point. Let's see how we do it. All right, so let's use our command line to enable the access point handoff, to limit the number of clients to that access point, and to configure a threshold. So let's configure the wireless controller WTP profile. There it is. And let's use one of the default profiles, which is the 11N only. Let's configure the radio. And let's set the access point handoff to enable. All right. And now let's move back and configure the handoff station threshold and limit it to only 15 clients. So only 15 clients will connect to that access point before the load balancing mechanism will start to work. And the last thing to do is to set the handoff RSSI. And let's use a handoff RSSI of 30. Now, in the case where our clients will try to connect to our access point, the controller, our FortiGate that serves as a controller, will signal the client to connect to another access point. One of the key topics that you will master using your Fortigate firewall is policies. So, what is a policy? Why do we need policies? And how do we configure policies? Well, a policy is a rule that when a traffic flows from one interface to the other, it matches different patterns of the traffic. It matches the interface that the traffic comes from, the destination interface that the traffic is heading towards. It also matches the source of the traffic, its IP address, if it belongs to a user or a user group. If it belongs to a specific device, it can be a PC, it can be a smartphone. And when traffic matches your rules, your specific patterns, then the policy takes the security profiles action, which is an intensive process that looks into the payload itself and looks for different patterns to identify the traffic, to look for viruses, to look for anomalies. We will look at IPS and antivirus later on. And then, when all goes well, the policy decides whether to NAT the traffic and whether to log it. Policy is actually a three-step procedure. Let's look at a very simple policy. We will create one now. Now, on our policy, the first part is the part where we look for matching traffic. Let's name our policy. Let's call it full access. And let's decide that we wish to allow any user that sits on a specific LAN. It can be your marketing division LAN, it can be your finance LAN. Each LAN will probably have a different subnet to get out to the internet over the outgoing interface, which is our WAN interface. Our WAN interface is the interface that is connected to our ISP. Now, in terms of source, we will allow any source to get out to the internet. We can also limit it to specific users or different user group. We can create a user or a user group using the plus sign. We can also limit the traffic to a specific device. So if we, for example, want only Linux devices to get out to the internet, we can limit it to a Linux PC. Now, we will not do it. As for destination, we are not limiting. We will let anyone get out to any destination, but we can limit the destination towards a specific address. As for scheduling, we can limit our policy to work on a specific day, on a specific hour, but we will not do it. Anyone can get out to the internet always. And the last part of the first step in our policy procedure is this service. We can limit this service to be HTTP, HTTPS, or any other service, any other protocol that we wish to limit our users, but we will not do it. Users can use just about any protocol, any service. And then we decide on the action. Are we accepting the traffic? Are we denying it? Or maybe we are using it as a learned policy. A learned policy is a very specific policy that actually triggers security profiles beneath that no one really knows that it's there, and it learns our traffic and creates a report that we can look into and see users' traffic, most used applications, threats, and so on. The second part is the UTM profiles. We can initiate any UTM profile, any security profile on our policy. And the third part is whether we are enabling NAT. We have seen how NAT works using a NAT overload, IP pools, or maybe central NAT. And then we decide whether we want our policy to be logged with log all sessions or only security events. That's the basics of a simple full access policy. If you enabled Web Application Firewall on your Fortigate, then you need to know of XSS, cross-site scripting, one of the most known and malicious attacks on web servers. More on XSS coming right now. To get more easy setup tips for your FortiGate firewall, subscribe now and don't forget to click on the bell notification and you won't miss anything. When you think of web apps, any web app, in its basic, it is built around three components. That's the very basic. There's HTML, the markup language. There's the programming language which adds interactivity into the page itself. We usually use JavaScript. And there's the CSS, which is responsible for the styling. Now, think of a web app that when a user enters an input into one of the forms fields or any place that a user input is needed. It doesn't sanitize between a pure data, that is text, and a malicious code. Malicious attackers use XSS for different reasons. It can be a harmful reason, such as changing the look and feel of the web app, its background image, or color or type of font, but it can also be used to steal cookies from the user, to grab screenshots of its computer, or to even insert a keylogger that will send any keystroke to a specific URL. There are actually two types of XSS attacks. The first one is reflected XSS, that is XSS attack or malicious script that is reflected on the victim's browser. And the second one is stored XSS, which is the malicious code that is stored in the web app database and is executed every time when the user calls the specific function. Now, what can you do with XSS? Well, just about anything. If you head over to XSS payloads, you can find out different JavaScript payloads that can be inserted as a malicious code on a web app field or form and can be used to capture keystrokes, can be used to take screenshots out of your screen, or even grab images from your webcam. So XSS is pure evil when it is used in the hands of the wrong man. Let's look at how the JavaScript itself looks like. So that's the JavaScript itself. Now, in most of the cases, the JavaScript code also takes the information that it grabs. It can be a screenshot from your computer or even your cookies that are being stolen and sends it to the attacker URL where they can grab it and use it against you. One very known attack is when you use XSS to steal some other user's cookies and then you head over to the same website and pretend to be that user. Five best tips for using your antivirus within your Fortigate. The first one, choose whether to use it in a flow-based mode or a proxy-based mode. You can see that in a flow-based mode, the features are quite limited, but moving into a proxy-based mode, you can see that you have much more options when using antivirus. The second tip, choose your database. There are actually three main databases that you can use within your Fortigate. There's a fourth one, which is a compact database, but you can use the config antivirus settings and set the different database. You can use the default database, the extended database, and in specific Fortigate modules, there's also the extreme database, which actually includes just about any signature. Our third tip is use grayware and heuristics. Now, when you scan using antivirus, the first step is to look for known signatures. The second step is to look for grayware. Grayware is not by definition a malware. It is an unsolicited program that usually downloads to your computer without you ever knowing about it. A good example is an adware. So how do you enable grayware? Again, config antivirus settings, set grayware. Now you can enable or disable. My tip, always make grayware enable. Alright, now for the fourth tip, use heuristics. Now what is heuristic? Heuristics, let's just, alright, let's config antivirus, but this time not settings, but heuristics. Now heuristics is actually an analysis of behavior, the way a file behaves. Now, Fortigate looks for different patterns, and if the file behaves in a suspicious way, you can determine what to do with it. Now you can set mode to pass the suspicious file, you can block the suspicious file, or you can disable the heuristic features. Now, why do you want to disable this feature? Because it adds up much more false positive events. So use it carefully. My fifth tip and the last tip is use hardware acceleration for antivirus scanning. Now, acceleration works only on the flow-based antivirus, not on the proxy one. And Fortigate models that features the NP4 or the NP6 can accelerate the antivirus processing to enhance performance. So use it by typing in your command line config IPS global, set npxl mode and choose none or basic. Basic actually enables the acceleration itself. And the last tip that I have for you guys is don't forget to subscribe to FortiTip. Let me show you the best application control tips for your Fortigate, and we start right now. To get more easy setup tips for your Fortigate firewall, subscribe now and don't forget to click on the bell notification and you won't miss anything. Application control scans your traffic, your network traffic for applications that you wish to control. Now it does so using the IPS, the Intrusion Prevention System engine, and its protocol decoders. Now, the order of the operation is quite significant. The first thing it scans is the application override, that is different signatures. The second thing is filter override, where you can group applications that have the same behavior, such as excessive bandwidth. And the last thing it does is scans for the different categories. So if you wish to block a category such as gaming, and yet you wish to enable a specific game such as the Battlefield game, you can do it. And let's just select the signature. And Fortigate will start by scanning application override. It will see that the Battlefield game is, let's make it allow, let's make it a monitor, in monitor mode. It will allow the game, still it will monitor it, keep logs of it, and then it will look for the filter overrides. Currently we don't have anything in the filter overrides, and then it will look at the categories where it will block any other game. When the IPS engine finds a match to an application, it tells your Fortigate that it found an application ID number. Now, Fortinet keeps a database of some thousands of applications. Each one has its own ID. If you wish to see the different IDs for the different application, you use the CLI, config application list, edit 0, config entries, edit 0, and then set application and a question mark. And now you can scroll between the different applications and their ID. The next tip may seem obvious, but I have seen cases where users created application control sensor and believed that it is globally enabled on any firewall policy. Well, that's not the case. Whenever you create an application sensor, name it, and then use it in your different policies, and the application sensor will be available only through that policy alone. Whenever you as an administrator block an application, don't forget that your users deserve an explanation why that application was blocked. So for an HTTP based application, you can use the replacement messages for HTTP based application. Make sure that it is enabled. Now, when you enable it, your users will get a blog page that will include the following information. The signature that detected the application, the signatures category, either gaming or peer-to-peer, the URL that was specifically blocked, the client source, that's the IP address of the client, and the server's destination. Now, another thing that the block page includes is the FortiGate's hostname and the UUID of the policy that was governing the traffic. It is good in an organization that you have many FortiGate devices. You can look up at the hostname of the FortiGate and tell which FortiGate actually blocked the traffic. Now our last tip, which we will include a specific video on it in the coming future, is traffic shaping. You can actually traffic shape any application and allocate guaranteed bandwidth or maximum bandwidth to that specific application. It can be your Netflix or whichever application you use the most. Now you configure a traffic shaper and you configure a traffic shaping policy. That traffic shaping policy can be determined on a specific policy and specific categories such as video and audio, where you can actually select different applications such as the Netflix application. Fortigate Captive Portal in 3 minutes. Here's how. To get more easy setup tips for your Fortigate firewall, subscribe now and don't forget to click on the bell notification and you won't miss anything. So you have outsourced employees connected to one of your interfaces and you wish to restrict the access to the network. What do? You use Captive Portal. How? Here's how. The first thing to do is to create a new user group, a user group that is dedicated to those outsourced employees. So let's create one. Let's use the guest as our user group, and let's use email as a method to deliver the password for that captive portal. The expiration of the account is 4 hours, but you can change it. That's the first step. The second thing to do is to create an administrator that is responsible only for the provisioning of the guest accounts. So let's use my name, let's use a password, and let's restrict that admin for guest accounts for the outsourced employees. Now the third thing to do is to head over to that interfaces that our employees will connect through, and let's move over to the security mode. Let's choose, usually it is none. Now we will use Captive Portal. We will restrict it to that outsourced employee group, and we finish the third step. Let's create a policy that will allow outsourced employees to get into the network, and outsource EMP. The incoming interface is the interface of the outsourced employees. The outgoing is our WAN. Source will be all and will be outsourced employee user group. Destination is all. Service is all. Alright. Now let's log out and let's get into the new admin page that will allow us to create password for those employees. Now let's use my email, and Fortigate will generate a password that we can print it out or send it via email. Now if we log out again and enter with our user, our super admin credentials, we will see that in our user group, we already have one member, which is the member that we have sent the password to that email. Hey everyone, this is the second part of how certificates work. We will unleash the mystery of certificate, and in this part we will look at asymmetric encryption. Well, asymmetric encryption works using a key pair, two different keys that are related mathematically. Now, one key, which is the private key, should be kept safe. That's the secret key. The second key is a public key. Anyone can use it, anyone can look at it. You can encrypt using the private key or using the public key. You cannot encrypt and decrypt using the same key. You have to use the second pair in order to encrypt or decrypt. Now, we will look at OpenSSL and how do we generate a key pair. One is a private key and the second one is the public key. But the beauty of asymmetric encryption or using a key pair is the fact that they're not only used in encryption, they are also used to authenticate the identity of the second peer. A server that wishes to have a digital certificate must generate a key pair. It must generate a public key and a private key. There are different algorithms that will allow it to do so. We will use RSA. Now we'll use OpenSSL, GenRSA, and let's name our key pair. Let's name it Fortigate, and let's contain it in a PM format, which is a container that will include both keys. And let's decide that the size of the keys will be 2048 bit. And that's about it. Now, if we wish to see both the public key and the private key, to inspect them individually, we can do so using the following command: OpenSSL RSA. Let's insert the file that we have just created, fortigate.pm, and let's get the public key out of it, and let's name it mykey.pub. Alright, it's writing it. Let's see how it looks. Let's open the key, and that's our public key. Now, if we wish to see the private key, we can use the following command: and that's the private key. So we have a public key and a private key, and those two are used when a server requests a certificate using a certificate signing request. It sends the public key as a part of its information. We will look later on how a certificate authority takes that information and actually creates a digital certificate plus a digital signature that will prove that he or it is the one that it claims to be. Hey everyone, back to Fortigate certificate, and in this part 3 we will look at hash functions. Now, what is a hash function? A hash function is a mathematical function that takes any input and produces a hash value. Now, the hash value is always in a fixed size according to the hash function that was used. The hash value is also called a digest, and it should be impossible to produce the same value for two different inputs. So the function is actually collision free. Now, a hash function must be quick. It has to produce the hash value very fast, and a slight change on the input should change the entire hash value completely. So even if we have a 1 GB file full of text and we change a comma in one of the sentences, the hash value will change completely. So we have the input, we have the hash function, and we have the digest, the hash value. Now, when do we use it? We use it for integrity. Whenever we send a file, it can be just about any file, and we want to check its integrity, that no one touched it, no one tampered with the bit stream. We make a hash value out of the file, and then on the other side we compare the same file using the same hash function. If the two hash values are the same, then no one tampered with the file. If the hash value changes, then someone probably touched the file. There are dozens of hash functions that are used just about anywhere. When a web server stores passwords in its database, they are being hashed. They are being hashed using different hash functions such as the SHA-256 or the SHA-512. To make the hash stronger, we also use what is known as a salt. We generate random numbers to be added to the password itself, and thus the hash value will be much more difficult to guess. Now, the term guessing is the right term, since hashes are in no way an encryption technique. They are not used for encryption. They are only a mathematical function, a one-way mathematical function that takes an input, turns it into another value, and there's no way back. They are not reversible. Alright, so enough with that. Let's move over to OpenSSL. Let's reproduce some hashes out of different inputs. And at the end, that will probably be part 4 of the series. We will recap what we have learned by now. That is symmetric encryption, asymmetric encryption, and hash functions. And we will look at certificate, a digital certificate, and understand how it all matches. Alright, so we'll use OpenSSL, but let's start out by using the echo command. And let's write down some text. I have a secret message. Alright, now let's grab it into OpenSSL. And let's use MD5. MD5 is a hash function that produces a 128-bit value. Now that's the hash value of that text. Now if I'll use the same text, but I'll change the E to an A, you'll see that I get another hash value, completely different hash value. Let's go back to the same text, and it will produce the same hash value as before. Now if we will use the SHA-256 hash function, you can see that we actually get the output as a 256-bit value. It is much stronger than MD5. We can also do it using the 512-bit, which produces stronger hash value. Now, how does it all have to do with digital certificate and digital signatures? We will look at it in our next video, which will be the last part of the series. But let's just look out at a digital certificate. And as you can see, we have the public key, which is the asymmetric encryption. We also have a signature algorithm, which is the hash function, as we just spoke about. And in part 4, we will see how it all mixes out with the symmetric encryption to make sure that we have confidentiality, authenticity, and integrity. One of the toughest topics to understand when we deal with security appliance is probably the world of certificates, digital certificates. Why? Because understanding certificates means that you have to understand what is asymmetric encryption, asymmetric encryption, and hash functions. Now, we will start with a video series that will try to lighten up the issue, and we will start with a basic introduction to symmetric encryption. We will do it using OpenSSL. So asymmetric encryption means, and that is the very basic meaning, that we take a plain text, we use an algorithm, which is a mathematical function that uses substitution and uses transpositioning, and we are using a key that is known to both parties. The key is the same. Later on, we will deal with the key space and what does it mean. And now we will take the plain text and we will use the algorithm together with the key to turn it into a cipher text. So if we'll open up a text file and let's write down Fortinet secret key, and now let's save it. Let's save the file as Fortinet. Let's open it again just to make sure that we have the plain text. And now let's use OpenSSL. Let's use AES 128. AES is a symmetric encryption algorithm. In our case, we are using a key space of 128 bits. That is 2 to the power of 128. And let's insert the Fortinet text and let's output as cipher text. Let's call it cipher Fortinet. We are asked to insert a password. The password is not the key. The password is part of the key derivation. So let's enter the password. Let's enter it again. And now we have a ciphertext. Let's look at the ciphertext. We have called the ciphertext cipher Fortinet. And there it is. That's the encrypted plain text. Alright, so here we are at the top 5 diagnostics command for your Fortigate, and we start with the first command, which may look a bit simple, which is the get system status. Now, this command is very basic, but it gives you a lot of information. It gives you the virus and the IPS database version. It gives you the serial number of your Fortigate. You can tell if you have a hard disk or are you using only a flash memory. It also tells you, are you participating in an HA cluster or not. It gives you information of the operation mode. Are you working in a NAT mode or maybe a transparent mode? Are you using another virtual domain or are you using only one virtual domain? So a lot of information in that simple command. This second command is the get hardware NIC and the interface name. In our case, let's look at our WAN interface. Sorry, it's WAN1. And that tells you of each interface its MAC address. Does it support any hardware acceleration? In our case, we support MP4 Lite. Do you have any dropped packets in your interface? Is the status up or down? Are you working in a full duplex or maybe half duplex? And what is the speed of your interface? In our case, it's 1 gig. Our third command is the get system performance status. Now, personally, I love that command since it tells you a lot of your Fortigate. Now, at the top output, you will see how many CPUs your Fortigate module supports. The following thing is the RAM usage. And at the bottom, the output shows your network traffic, the amount of average sessions per minute, and so on. So you have your CPU usage, you have your RAM usage, and your network usage. Next up is probably most known when you deal with the Fortinet firewall, and that is the diagnose debug flow, which actually shows you the flow of your traffic from the CPU perspective. So you have to enable it. Let's enable. And then you use the diagnose debug flow. You usually use filters, since if you are not filtering your traffic, there could be tons of traffic that will be shown on your command line and it won't be so easy to analyze. So let's filter a specific address, which is the 10.0.3.16. And now the next thing to do is to diagnose debug flow and trace, and let's use a count of 10 packets to show. And it shows us tons of information from the specific source host that we have chosen to just about anywhere that the traffic flows. It shows us the source NAT and the destination NAT, and it shows us the policy that is being used. A great tool for debugging and troubleshooting. Alright, now the next command is the diagsys session list, which shows you the sessions that are being handled on your Fortigate, and that also shows us tons of information. You can see the different protocols that are being used. You can also use it using specific filters or grabbing different source address, and that will show you a limited portion of the information that is relevant towards a specific host only. And Our last command is the diag systop, which is similar to the top command in Linux, and that shows you each and every process in your FortiGate. It shows you the process name, the process ID. It shows you its state. Is it asleep or maybe it is running? It shows you how much memory is being consumed and how much CPU is being consumed. Whenever you have issues with one of the processes in your FortiGate, that is probably one of the first places to check. And before we end this video, please don't forget to subscribe. Your Wi-Fi throughput can vary for different reasons. Noise, misconfiguration of the access point, co-channel interference, adjacent channels, and so on. But one of the main reasons is obstacles in your physical space. Obstacles that will make your RF signal reflect and propagate to different directions. One of the mechanisms that are used in Wi-Fi is the guard interval. It protects symbols in your packets from getting back and damage other symbols. Mostly we use a guard interval of 800 nanoseconds, but since 802.11n we can also use short guard interval of 400 nanosecond. It can help you increase the throughput in your Wi-Fi deployment, but don't use short guard interval whenever you have high density deployment. Let's try it out, and please comment me back on this video and tell me if it helped you to increase your throughput. I can tell you that in my case, it actually helped me to increase my throughput in about 10%. So let's do it. So let's move over to the CLI. Let's configure the wireless controller WTP profile. And now let's edit one of the most used access points, which is the 4221. Let's configure its radio. Alright, let's see the full configuration. And as we can see, the short guard interval is disabled. So we can set the short guard interval to be enabled. That's about it. Now, don't use it in any deployment. Learn what happens in your network in real time and make decisions by it. Hey everyone. So you have your FortiGate and its switchboard includes physical ports. Each can be configured with its own IP address or be associated to a virtual switch, either a soft switch or a hardware switch. That is, we are actually creating switches within the physical switchboard. But what is the difference between a soft switch and a hardware switch? Well, the difference is that in soft switch, the implementation itself is done at the software level and not on the hardware level. That is similar to saying, okay, port 1, port 2, port 3, you all belong to a soft switch that we will name it marketing, and it will have an IP address of 10.0.0 and so on. In a virtual hardware switch, the implementation is done over the physical ports themselves, where each port, each interface is configured in its hardware level to be a part of the same hardware switch. That is a much superior way to handle traffic, and in terms of performance, it makes a huge difference. Now, whenever traffic enters the switch and it is destined to one of the interfaces that belong to that switch, decisions are made by the physical switch itself, its forwarding table, which is actually the MAC table. Alright, so let's configure a hardware virtual switch. Alright, so let's move over to our command line, config system virtual switch. And now if I'll type the get command, I will see that currently I don't have any virtual switch already configured. So let's name one. Let's call our virtual switch, let's call it marketing. And let's set it up from the physical switchboard. All right, and now let's configure the different ports that will make out this switch. So let's use internal 4 and let's use internal 5 also, and let's use internal 6. All right, let's get back to our, all right, so now let's Let's use the same command as before. Config system switch. Config system virtual switch. And let's see if we have a switch that is configured. Yes, we have. Here's our marketing switch. All right, now let's refresh our interface pane to see our new virtual switch. And there it is. Now, if we will head over to our setting page of that switch, we can configure its IP address, its management. Let's use LAN2 as our alias, and let's get him an IP address, and that's right. I'm using the same. Let's allow anyone to connect to it using HTTP and HTTPS, and let's allow ping also. And every device, every appliance that will connect to that subnet will get an IP from its DHCP server. And let's also add up device detection. Okay. And there we have it. We have a hardware virtual switch with its own subnet, with its own DHCP server. Any appliance that will connect to it will get an IP address from its pool, and any traffic that will head up to one of the interfaces that is within the marketing switch will be forwarded using the forwarding table. One of the coolest features of your FortiGate is its ability to packet capture just about any traffic that flows from different sources towards different destinations. Now you can capture packets using two ways. The first one is using the GUI itself in network packet capture, and you can enable different filters, but the way that I like is the TCP dump way. That is doing it in the command line interface. And I didn't mention TCP dump for nothing. The syntax is very similar. Now, if you use the GUI option, you can import the results into a pkf file and then open it in Wireshark. But we will use the CLI way, as I find it much more quicker to analyze. So the basic syntax for capturing packets is the diagnose command, and then we'll use this sniffer and packet. And now we will choose which interface to make the sniffing. Now we will not choose specific interface, so we'll use the any interface. We will not use any filter right now, we will use it very soon. The amount of verbosity, the amount of details which we will use is 4. Packet count will be 10. And we'll also use a timestamp using the A command. Now let's open it so we can see it much clearer. And we can see that we have action in our WAN1 interface with a source of 10.0.3.139 towards the Fortigate appliance itself, which is in the 10.0.3.16. We have different TCP packets using different flags, and we will use a specific filter that will define the if we can see any action that is being done using the ICMP protocol. If we will use the same command without the A at the end, we will get the same results, but without the timestamp. So use it when troubleshooting packets. Now, if we'll want to use, let's add the A. If we'll want to use a specific filter, as in the ICMP protocol, so we will see that once we enter the name of the protocol, and take a good notice, we have only 10 packets that are being shown. We can also use 20 packets and we will have 20 packets. We can use many filters in our command. Now you can look at the Fortinet documentary to see which filters are available when doing packet capture, but the most used are source and destination. We can determine specific host and specific protocols. So if we use the diagnose sniffer packet any, we can use host 10.0.3.139, which is my Mac, and ICMP as the protocol that I'm looking for. And we will use the verbosity, the level 4 verbosity, which is the default verbosity.